Hey guys, uh, let's start today's lesson. Make sure you have your notebooks out, fresh new page, new section. There's your title, 2.3.2. Find it in the textbook so you can follow along as well. So pause this video whenever you need time. Go ahead and get your title in. Okay, you now have a complete list of the 3 triangle similarity conditions. So angle, angle, side, and side, side, side similarity that you can use to verify triangles are similar. Today you're going to continue to practice applying these conditions, and we're going to use a flowchart or flowcharts to organize our reasoning. So 90, decide if each pair of triangles below is similar. Use a flowchart to organize your facts and conclusions for each pair of triangles. So let's take a look at that first one, number 90. So why don't you pause the video for a second and just study it. Okay, so hopefully you paused and gave yourself enough time to look at it. So it looks like if we rotate this around a little bit, we can get it to match up. Looks like we're going to have to rotate it and reflect it. So it looks like, I'm going to highlight the sides here. It looks like JL is going to correspond with IH here. And then it looks like LK right here will correspond with HG. And then JK here will correspond with IG. Okay, so just by looking, we can't use, well, we could use side, side, side similarity. However, we don't know this third side, but we could figure it out using Pythagorean theorem. What we could do is use side, angle, side similarity, because we already have a pair of angles that are congruent. And then we already have 2 pairs of sides that sandwich that angle that could possibly be in proportion to one another. So we need to check that. So here's how we're going to check that. We're going to say LK corresponds to HG, as we already highlighted. LK is 9, HG is 12, and if I reduce that, that looks like it's in a 3:4 ratio. Now I'm going to check the other side, which is JL corresponds with IH. That looks like a 12:16 ratio, which is a 3:4 ratio when we reduce that. So you can see those ratios are the same for the sides. We've got a pair of congruent angles in between, so then we can say side, angle, side similarity. So let's get a flow chart going and organize our stuff here. So first bubble, and so we just need to say side, angle, side similarity. So let's say, so basically we want to put this work into the flow chart. So we'll put this first one right here because we need to say that the sides are in proportion. So we can we're just transferring that in there. LK over HG is 9/12, which is 3/4. So we're showing that this is a 3:4 proportion. Okay, so that's our statement. Okay, so our reason for this statement is simply, I mean, all we did was math there. That's basically math work. So our reason we want to give, we'll just call it computation, which just means we did the math work. Okay. All right, and then we want to do the same thing with this other pair of corresponding sides as well. We want to put that in there. So we're going to say JL corresponds with IH, and that's JL is 12, IH is 16, and that's also a 3:4 ratio. So we're showing that they match up. They have matching ratios here. Well, that's also computation. That's our reason. And then what are we missing? It looks like we're missing these. We have to say these angles are congruent. So that we'll put that right here. So we'll say angle, we can just call it angle H, that can't be mistaken for anything else, is congruent to, and then we can say angle L and the other one. The reason why that's not computation. We didn't do any math there. That was given. So we will write given. Okay, and then that's enough to say side, angle, side similarity. So down here, we're just going to name the triangle similar. So it doesn't matter which triangle you name first. I'll just do this first one right here. So we'll just call it IHJ. So triangle IHJ. H, not J, G, is similar to, not congruent. And then IH was, looks like if we say IHG, then we're going to have to say JLK. Triangle JLK on the second one to make sure it's all corresponding. And then we'll say the reason is side, angle, side, similarity. And we want to make sure we have arrows here indicating a flowchart. That's the first one. Okay, let's go on to the second one. Pause the video and sketch that diagram and study it. Okay, so how do we know what sides? It looks like we don't have any angles at all. So we can't use angle because we don't know any angles. We can't use side angle side because again we don't know any angles. So it's going to have to be side 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 similarity. So let's match them up here. Okay, so 14 is the longest side in this one, so it's got to match up with the longest side in the other one. Okay, 9 is the second largest side, so that's got to match up with the second largest side over here. And finally 8's the smallest side here, so it's got to match up with the smallest side there. So let's check to see if we're all in the same ratio here. So let's see, XY corresponds with PR, and that is XY is 9, PR is 5. That's a 9:5 ratio. So everything else has to be in a 9:5 ratio for these to be similar. So if we check ZY, so ZY corresponds with QR. ZY is 14, QR is 7, and that's a 2-to-1 ratio. So as you can see right here, these ratios are not the same. Therefore, these triangles then we say are not similar because their side lengths are not in proportion to one another. It's that simple for that one. Okay, go ahead and pause the video, draw that third diagram in number 90. Okay, this is one of those where the smaller triangle is lying directly on top of the larger triangle itself. Alright, so remember this has to be similar because a dilation would have to occur to get the larger triangle, and therefore they're similar. That's the definition of similarity. So, anyways, I mean, as far as not the technical definition of similarity, but what we were talking about in class. So here you got a couple of angles right here that are congruent. All right, and I suppose we could look at the sides and see. So we have some side lengths, like this whole side length is what, 11.5, and the smaller one is 9. Okay, but however, we don't know this whole side length, right? We don't know what this is. So we can't do that. But if you remember, I think we can use this angle right here, right? Because both triangles share that angle. Therefore, it has to be the same angle. So therefore, we could say these are similar because of angle-angle similarity. So when we make our flowchart, let's just say that, let's say angle NSM. So angle NSM, don't just say S there because it could be the other one, is congruent to angle TVM, and that was given to us. Okay, and now the other angle, the one that we pointed out right here, we could just say that could just be angle M. So angle M is congruent to itself because they share it, right? So we'll just say the reason is shared angle must be congruent then. And that's enough. Those two statements are enough to say that these two triangles are similar because of angle-angle. Okay, so we're just going to say, okay, this is angle-angle similarity, so we're going to say triangle, we'll say the big one, TVM, triangle TVM is similar to triangle, and then it's going to be NSM for the smaller one. Make sure we get those arrows in for the flowchart. And that's it for that one. Skip a line right and then go ahead and write number 91 here. It says, for the diagrams in problems 290, what are the lengths of the segments listed below? If it is not possible to calculate the length of the segment, explain why not. So JK. So let's go find JK. That looks like it's right there. So can we find the length there of JK? Hopefully you're thinking, yes, we can. If you were, you're right, because we can use the Pythagorean theorem, right? So the hypotenuse is always across from that longest leg, so we can say 9 squared plus 12 squared equals, say, JK squared. 81 plus 144 equals that segment JK squared. Okay. Now when we add these together, it looks like we're going to get 225 equals JK squared. Okay, and then we just square root both sides here. Looks like JK is exactly 15. So, okay, that one's done. Let's go back and look, see what other ones they want. VT over here, VT. All right, well, we could use a proportion. Remember, these triangles were similar. We could use a proportion. However, we don't have this side. This is the corresponding side in the other triangle that corresponds to VT. So we can't use a proportion because we don't know what NS is right here in order to do that. So that would be a reason you would just say not possible. We don't know the length of SN. Okay. If we did know the length of SN, we could use a proportion to figure out what the length of VT is right here, but we can't. And then TN is the last one. So TN is going to be right here. Same diagram. So we can do TN here. Okay. So let's just call the length of TN here. We're going to call that X. Okay. And we're just going to use a proportion. So let's do the smaller triangle. Let's match up the sides. So that side matches up with this larger side in that triangle, right? And then this side and then this side is going to match up with this longer side of the triangle. And let's set up a proportion and solve this. So let's work on those first two sides. So we can say what SM, which is 9, corresponds to VM, which is 11.5. And that's got to be in proportion or equal to the other one. So NM, which is 11, this one, over this whole length right here. Well, now think about what that whole length right there is, right? Wouldn't it just be X plus 11, whatever X is? But now that we set up that proportion, we can cross multiply here and solve for X. So we get 9 times X plus 11 equals 11 times 11.5. So punch that into your calculator there. Let me pull out my calculator here. Okay, so 9 times 11.5 is 103.5. Okay, we're going to distribute here. So 9x plus 99 equals 103.5. Subtract 99 from both sides, and we get 4.5. And then we're going to divide by 9. So that looks like it's 1/2. X equals 1/2. Alright, so there you go. That tells you the length of TN, so then we can say TN equals 1/2. Problem I want you to throw in your notes here is number 93. Examine the triangles at the right here. And then I want you to answer questions A, B, C, and D. It says, are the triangles similar? So if I reflect this over, it looks like I think we can, well, I'm sorry, not a reflection. We'll have to rotate it and then move it over. So looks like CA will correspond with RU here, okay? And then TA will correspond with UN, and then CT right here with RN. And it looks like we might be able to use side, angle, side similarity, okay? Side, angle, side similarity, but you got to check that those side lengths are in a proportion to one another. If they are, then you can say they're similar. Okay, and then go ahead and work through and answer these questions. Okay, hopefully those notes help, and go ahead and work on the rest of your assignment. Thanks, guys. I'll see you next week.